Hey, what's going on, guys? Nigel here. Today we're going to be doing question 2125 on LeetCode, number of laser beams in a bank. So you're pretty much given a binary string array, which represents the floor plan of a bank, right? So, and whenever that binary string has a 1, it means that coordinate in the grid has a laser. So, for example, in example 1, you have 0, 1, 1, 0, 0, 1. That means in position 1, there's a laser beam. So 0, 1, 1, 0, 0, 1. And the question is asking you to find the number of laser beams in the bank. And a laser beam is basically created when a laser points to the laser in the next row, right? And there are different rows. And also, like, one thing to notice is there can't be any laser beams like going like across, rows that already have laser beams in them. So, like the first row doesn't go to the last row, right? Because it's going to the third row. And the approach is pretty simple. It's just to count the number of lasers in each row, right? And then just multiply from the next row, right? Because look, if you have one laser beam here, right, it always goes to all the laser beams in the next row, right? So that's gonna be 2, right? Right? Each one goes to 2. Each one goes to 2. So that means between any two rows, right? Like row 1 and row 3, the number of laser beams would be the number of lasers in row 1 multiplied by number of lasers in row 3. So that would be 3 times 2 here. And same thing for the last two rows, right? Like you have 2 laser beams here in the third row and then 1 laser beam in the last row, right? So 2 times 1 is 2, right? So you have, what is that? You have 2 plus 6, right? So that's why you have 8. Yeah, so that should be pretty much it for this question. And let's do the code. Okay, so yeah, if we only have 1, right, there won't be any laser beams created because there has to be at least 2. So if you only have 1 row, then there's going to be no laser beams. And what we're going to do first is count the number of laser beams in each row. And then after we count the number of laser beams in each row, then we'll go through the bank again, and then we'll just find out how many lasers from the previous row we have and multiply from the current row. Alright, so let's do that. So we'll use a array, keep track of the number of laser beams. Lasers, and that's going to be that size. Initialize is 0. And I would be the row index. Oh, I can't type today. So now we just have to check each character, right? So if it's a 1, then we can just increment the number of lasers for that row. If index character at index j is equal to 1, then just number of lasers of the current row I is incremented. Okay, so that's for counting laser beams. And now we can find the number of actual beams created. This should be count number of laser like devices, not laser beams. So now we're counting the number of laser beams. So we're gonna start at the first index, right? Because we have to look at the previous ones. If we're at 0, then there's nothing to look at before. So we'll start at index 1. And we have to look at the previous value. So previous row would be, let's call that j. And while we don't have any like laser, right? Like if we're at 0, 1, 2, if we're at 2 here, we're going to be looking at 1. Okay, 1 has nothing, so we'll go back and look at 0 now. Oh, 0 has something, so we can calculate from 0. Because we want to look at the previous one, right? Like not like too far behind. Like if we're looking at the last row, then we'll look at the a third row instead of the first row, because the third row is the closest, right? Like it says there won't be any security devices in between two rows. It goes to the closest one. So while there's no laser beams, we can just go back and look at that previous one again. We're decrementing Jade, look at the one before. And if you don't find anything, then you can just return, continue to the next row. Okay, so previous row lasers is going to be number of lasers at J, and then our current number of lasers is at I, because we're currently at the ith row, and we went back to look at the row that has lasers. So if we're at 3, then the previous would be, we're at row 3, the previous row would be the first row, because first row has the lasers, so it's going to be 2 and 3. So 2 times 3 is the number of laser beams, right? Because each one goes to the next ones. So let's total beams equals 0. Total beams is previous incremented by previous times current value, and then we can return total beams. All right, so let's see. Yeah, so we're basically just counting the number of laser devices in each row, and then just multiplying from the previous row to get the laser beams that are being transmitted or sent. So time complexity, basically we're going through each row in the bank, and then we're going through each string from each bank. So we're going to be, time complexity is going to be, so this is n times m. So n is the number of rows in the bank, and then m is just the length or like the width of the grid, like the n in the matrix, or rather the length of the string. And then space complexity is just going to be O of n, because we're pretty much just keeping track of the number of laser beams in each row. And let's see if this works. Example test cases run code. All right, it looks like it works. Submit. All right, we're good. That's pretty much it. Thanks for watching. Let me know in the comments if you have any questions or if I messed something up. And I'll see you guys soon.